Hello friends, today we will see practice set 1.3. But before to start the questions from 1.3, we have to see the tests of similarity on which the examples are depending. So what is test of similarity? You know, you have learned in the last standard the test of congruency. Two triangles or two figures are congruent. That means when we put them on each other, they stick very uh, neatly to each other. That is called the congruent figures. When two pages are put on each other, they resembles or they stick each other accurately. This is called congruency. But what is similarity? You have seen the butterflies on the wall. All these butterflies look alike. These butterflies are the example of similar figures or similarity. See, all these butterflies are in particular dimension, they are increasing or decreasing. Now see these triangles. In these triangles, this left side of every triangle is in proportion. For example, it is half and 1.5 greater. Therefore, this is 15 and this is 2 times greater, that is 20. Therefore, there is a relation between these left sides of every triangle. There is the same relation between the bottoms or bases of the same triangle. See, this 4.5 is 1.5 times of 3. Like the 15 is 1.5 times of 10. Like that, 4.5 is 1.5 times of 3. This 20 is 2 times of 10. This 6 is also 2 times of 3. Now see, this 7.5 is 1.5 times of 5. That means 5 into 1.5 is equal to 7.5. 5 into 2 is 10. This is the relation, this is a particular relation between these triangles. Therefore, these triangles are similar triangle. Here, measures of angles are not given, only the measures of sides are given. Therefore, these triangles are similar to each other by side test, because measures of only sides are given. Therefore, this test is known as SSS test. Now, look at these two triangles. In this triangle, the measures of the upside angle is x degree. In this triangle, the measure of this upside triangle, that is angle P, is also x degree. Measure of angle A is also x degree. Measure of angle P is also x degree. These two angles are congruent. Measure of angle at the base, left side at the base, is y degree. Measure of angle at the base and at the left side is also y degree. Therefore, these two angles are also congruent. Measure of angle at right side in the base, measure of angle at the right side in the base are z degree each. These two angles are also congruent. Therefore, if the corresponding angles of one triangle is congruent to corresponding angles of another triangle, then these two triangles are similar by AAA test. But this AAA test is not much in use. It is useful, but it is not much in use, because there is another alternative to this triangle, to this similarity test. Which alternative? See in this figure. Here 65 degree, here is 65 degree. These two angles are congruent. Here upside angle is 55 degree, here upside angle is 55 degree. These two angles are congruent. Then the remaining, this angle will be 60, because sum of the measures of all the angles of a triangle is 180. The sum of these two angles is 120. Therefore, remaining angle C will be 60 degree. Here, remaining angle R will be also 60 degree. Therefore, these two angles are, if not given, then only or thereafter they are also congruent, because they are remaining angle and their measurement occurs after subtracting from 180 the sum of these two angles. Therefore, the remaining angle is also congruent. If two angles are known, then and they are correspondingly congruent, then these two triangles are also similar by AA test. Now see on this similarity test, and there is also one test, SAS test. That means if the ratio of, suppose here 60 degree, 60 degree and 60 degree. These triangles are similar by SAS test. Side angle side, side angle side, side angle side. These three angles triangles are similar by SAS test. All these tests we have to use while studying the examples from practice set 1.3. Now look at the first example from practice set 1.3. Here in this figure there are two triangles. One is triangle ABC and another is triangle EDC. We have to find whether these two triangles are similar or not. We have to find whether these two triangles are similar or not, and if they are similar, then by which test they are similar. See, I am writing like this. In triangle ABC and triangle EDC, we have to compare. This is the step where we are going to compare these two triangles. Angle ABC is equal to angle EDC. Reason 75 degree each. That means both of these angles are of 75 degree. Therefore, they are congruent. Here 1. Then angle ACB is congruent to angle ECD. Here reason common angle in both the triangles. This ACB and EDC is common angle in both of these two figures, in both of these triangles. Therefore, these two angles are also congruent. Therefore, triangle ABC is similar. This is the symbol of similarity. Similar to triangle EDC by AA test. Here is A and here is A. AA test, and from 1 and 2. Equation number 1 and 2. In geometry, you have to give the proofs. These are proofs. Proofs means purava. If you are going to write the steps, you have to give proof for every step. Therefore, this is written here and it also carries marks. If you don't write this, you will lose your 1/2 marks for each step. Therefore, remember, while writing all these steps, you have to give proofs also. If not, then you will lose marks. Okay, these two triangles are similar and test is given. Here such types of examples are for 1 mark. Now look at this second example from practice set 1.3. Here are two triangles given with their measurements of sides. Now see, name of first triangle is triangle PQR and name of the second triangle is triangle LMN. If we here only the measures of sides given, then you can apply the test of AA or SSS. Which test? Side. Only side. SSS test. Therefore, see, in triangle PQR and triangle LMN, PQ upon LM is equal to 6 upon 3 is equal to 2 upon 1. This is 1. QR upon MN is equal to 8 upon 4 is equal to 2 upon 1. This is 2. And PR upon LN is equal to 10 upon 5 is equal to 2 upon 1. This is 3. Here, by observing these three equations, we can see that the right side is same. 2 upon 1, 2 upon 1, 2 upon 1. Right side is same if the one side of all the equations are same. 1, 2 or 3 equations may be there. If right sides are same, then the lefts are automatically same. Therefore, we can say PQ upon LM is equal to QR upon MN is equal to PR upon LN from 1 to 3. From 1, 2 and 3. By this, we can say that triangle here, there is no place, so I am writing here triangle PQR is similar to triangle LMN by SSS. Now look at this example number 3. Here is a ground level, and on this ground pole PR and pole AC are erected. That means there are two poles on the ground. The measure of first pole, that is pole PR, is 4 meter and measure of second pole AC is 8 meter. Here RQ is a shadow of first pole. If there is a sun in the sky, then this pole will have a shadow RQ of 8 meter, and this pole AC has a shadow CB which is X meter. We have to find the measure of this shadow of this pole AC. How will you find? You must know that when two poles are erected on the ground, and by those poles and their shadows, they make triangles, and those triangles are always similar. Therefore, these two triangles are similar. Triangle PRQ similar triangle ACB. Here reason triangles made by shadow. Triangles made by shadow. Therefore, if these two triangles are congruent, then their corresponding sides are in ratio. It is called as CSST. See, right, like this. PR upon AC is equal to RQ upon CB. Here reason is corresponding sides of similar triangle. CSST. Here is 6. Okay. And now see, what is this? If two triangles are similar, then their ratio of their corresponding sides are congruent. This is called corresponding sides of similar triangle. We will use CSST for all these sentences. For long sentence, we will always use CSST. That means corresponding sides of similar triangle. Now put the measures here. PR is equal to 4, AC is equal to 8, RQ is equal to 6, and CB is not known. It is given X here. Now, if two ratios are congruent or equal, then their cross multiplications are equal. 4 into X is equal to 6 into 8. Here, X is equal to 6 into 8 upon 4. X is equal to 4 1s are 4, 4 2s are 8, 6 2s are 12. X is equal to 12. Therefore, BC is equal to 12. Therefore, length of shadow BC is 12. Here we conclude today's lecture.